Good day everyone, my name is Mubarak Yusuf and today we'll be talking about pressure volume loop. As we all know, pressure volume loop is a very important concept in cardiovascular physiology. So today I will try to walk through the pressure volume loop in a very easy way. I'll try to make it very easy and we'll try to integrate our heart sound into it, and also we'll try to integrate our both our physiological heart sound, our pathological heart sound, and if there's time we can integrate our murmurs into it also. So let's start. This is a pressure volume loop whereby the pressure is plotted on the y-axis and the volume is plotted on the x-axis, right? It's a very important graph to draw. Just draw it. It's just like this is the way you draw it. And now let's integrate let's explain what each line means. Here by our left hand side, we see a very straight vertical line going straight down. It goes this way, and this is our isovolumetric relaxation, right? And when we talk about isovolumetric relaxation, this is a time whereby the ventricle is relaxed, but there is no change in volume in the ventricle. The ventricle is just relaxing, depressuring, but there is no change in pressure in the ventricle. So here we have isovolumetric relaxation, right? Then after isovolumetric relaxation, we have the graph going this way towards our right hand, towards the right, and we have, this is the phase whereby we call it filling phase, right? This is the filling phase whereby the ventricle, now the pressure in the ventricle is lower than the pressure in the atrium. Then we now have our mitral valve, our tricuspid valve opening, and when they're open, we have rapid filling. So here we have this phase, we have our mitral valve open. Here we have our mitral valve opening, and now we have our filling, right? And when the mitral valve open now, then we have filling, and here we can say this is end systolic volume, right? And because this is the amount of volume left after systole, the amount of volume left after systole, is our end systolic volume. Then after our mitral valve open now, we now have rapid filling. You can see the filling here. It keeps filling, all to the extent that, look, the volume now, the left ventricle is now ready to eject out blood. It's ready to pump out blood. It now starts developing pressure. Just as we have our isovolumetric relaxation, here also we see another vertical line going up. This place going down, this place going up by our right hand side, and this we call it isovolumetric contraction, right? Because here we have isovolumetric contraction, the ventricle is contracting, but at this phase of the contraction, there is no ejection. Because there is no ejection, that's why I call it isovolumetric contraction, right? And here we can call this phase our end diastolic volume, because after isovolumetric contraction, the next thing we have is our ejection phase. But before we talk about our ejection phase, here we have our mitral valve closure. Our mitral valve closure right here. So then, when we now, after the isovolumetric contraction, I said earlier that we have ejection phase, right? And this is when we have our aortic valve open, right? Because the pressure in the ventricle now overcome the pressure in the aortic valve, right? And the aortic valve now have to open, then you have ejection phase, and this phase is called ejection phase. And after ejection phase, then back again, we now have our isovolumetric relaxation. So basically, this is our pressure volume loop. And I hope this basically simplify everything. And probably the next video we will talk about our heart sound into our pressure volume loop and our heart murmur. Thank you very much. I hope this helps.